Now, as we know, all links on the network has to be assigned an IP address. So it's the same when you start deploying IPv6 addresses. All links on the internet, all links on the network must be assigned a IP address. Now, what happens is these links, what we call the connection links that are used to connect the user's LAN segment together, for example. So we have to come up with precious IP address to label this IP address link, okay, for connecting purposes. But the routers do not really want to learn the WAN link, because the IP addresses here is mainly used for local consumption, the next hop, okay. So routers doesn't really want to learn the WAN IP addresses. Router really wants to learn user LAN segments, right? We don't really want to learn our WAN link, because no users, no servers actually stay on the WAN link. So what happens, but we still need to assign IP addresses to the WAN links. So when you turn on routing protocols, what happens is the routing protocols will learn the WAN IP addresses as well. So if your company has a lot of WAN links, you are learning a lot of WAN IP addresses that you're not really interested in. You're not really interested in learning. You really want to learn the user's IP address, the server's IP address, not the WAN IP addresses. But because these connecting links have to have IP addresses, the routing protocol advertise those IP addresses just like any other IPv6 address. So when IPv6 was created, okay, I guess they took in the comments made by the IPv4 customers that they are learning a lot of unnecessary IP links. So IPv6 protocol came out with this idea called link local address. So you can assign link local address for those interconnecting links. For example, the WAN link here, and this WAN link will not be advertised to other routers except for connecting purposes. So this link local address will be a typical IPv6 address, but then of course it has a special prefix telling the IPv6 routers that this is a link local address. As such, this kind of WAN links, which the routers are not really interested in learning, is not advertised through the IPv6 routing protocols. So remember, link local address have a prefix of FE80. So you basically assign IPv6 address on the WAN links with link local addresses to connect the user networks together via the WAN links. And because the WAN links here are using link local address, these link addresses are not advertised, and they are simply used as next hop IP addresses. That's it. Now imagine the IPv4 world where we can take a large class A address and subnet it into many smaller subnets. So we can easily summarize all these small slices of class A subnet addresses back into the same class A address, thereby reducing the number of routing updates. But the problem is, as we go down, as we are running out of IP addresses and we start going down to class A and class B and even class C addresses, in particular class C addresses doesn't summarize well. So with IPv6, IPv6 has a very large addressing space just like class A. So we can have many subnets created, usable subnets created from the prefix address, like a class A address. Now the reverse is true, because all these customers' address are derived from the same common prefix, like a, if you want, think of it as a common class A address. We can easily summarize all these customers' address into a single prefix address, and the benefit is we can reduce the global routing table, because we do not have to exchange so many subnets information between routers.